Hello, welcome to this talk about Mind the Gap between ALM, Application Lifecycle Management, and MBSE, Model-Based System Engineering. My name is Etienne Julio, I'm the Vice President of OBEO. This talk will speak about a current issue in the industry, is the gap between the system design on one side and the ALM to manage the planning, the issues, test, the quality. And I will focus first on one aspect of the ALM, the requirement, and how we can ease the collaboration between the two worlds. The first question you have to raise when you think about this is, when do you have to manage this kind of collaboration between requirement and system design? Is it first you have to do all the requirements, the textual requirements, and then doing the modeling? Or do you have to do the requirement and the modeling in the same time? The answer comes from the Arcadia methodology, where you can see that it is an activity which has to be performed in the same time when you are designing your system. Sometimes you need to do requirement engineering because you need to express constraints about regulations, about documentation, which are easier to express in textual word. And sometimes you need to have more structured data, and using models is clearly more convenient. And sometimes, upfront to this design, you receive from your customer some requirements which are expressed in your ALM. But you have then to have a kind of bidirectional synchronization or a link between the two activities which have to be operated in parallel. Currently, how you are doing when you want to map a requirement to a system design? You have first to open your requirement tool to select the requirement to export, then to export to a standard format, for example Recif. Then you open your system project in your workbench, you import your Recif file, it could be several actions of course, you move the requirement in the right folder or package, you open a system diagrams to show graphically the associations, you add the requirement to the diagrams, and then you associate the requirement to a system element. Just for one requirement. So imagine you have to do this for all the requirements of a complex system. It could be several thousand times all this process, and of course you have also to do this for each versions, for each iteration. It's clearly painful. So based on experience and based on what we saw, we detect as a real issue of the user, we focus in our energy on the ergonomic aspect with very simple solutions. Just drag and drop. How it works? You have on one side your ALM tools, which is deployed on the web usually, and you have your system engineering tool. In this case it's Capella, an open source tool for doing MBSE, and you want to do something very ergonomics. So for doing this, you just select in your ALM with the classical UI of your ALM with searching, completion, anything you are used to use today, and you just drag and drop in your models in one actions. So let's animate this from a system modeling point of view, which means that it is the end user is a system engineers which use Capella, which has already the workbench on his laptop. So this first action will be to take a requirement, to drag and drop without breaking his Capella experience. He doesn't have to leave the tools. He will use his operating system, for example Windows or Mac and others, to split the screen and to be able to keep open his existing diagrams he is working on. And then, that's all. The tool will associate and visualize the requirement associations, and it could occur in any system, for any system element and for any diagrams. Under the hood, the principle is to hide every intermediate step: authentication, the requirement proxy creation, I will come back on this later, the traceability link creations, and the graphical rendering. And of course, thanks to this kind of link which has been created, the user can update and refresh for following versions. So in actions, you see on the left side the Capella workbench, and on the right side an ALM. And you can see that I just drag and drop the title of the requirement and I move it on the diagrams. For the first time, it's asked me the credential. It let me the ability to select and to configure which kind of work item could be considered as requirement. Then you will see directly on the diagrams the requirement which has been imported and stored in the right place. For the second times, you just have to drag and drops, and that's all. All the configuration is already made, so it's very, very simple. So you could imagine how fast and how efficient it is when you have to manage lots of requirements, and it also helps to create an experience where the two-word textual requirement and modeling, system modeling, are made in the same time. So now, you can see on the workbench, I have some information about requirement. So if I import a requirement, how I will have to manage the duplication of data. For system engineering, it needs an easy access to the relevant requirement, so you need to have some data. But also for the requirement engineering inside his ALM tool, you need also an easy access to traceability to the system element. So the way we solve this is just to don't duplicate. We don't manage in two different places some data with risk of conflict. We just, in the system engineering side, manage some minimal proxy of the requirement. They are just the minimal information about the ID of requirement to manage the incrementality of the update and the traceability. The name, just to avoid some query to the server to provide good performance, and just the type also to know which kind of requirement it is. We don't import the descriptions and other characteristics which need to be directly inside the ALM. And if the user wants to easily understand what it is about this requirement, in which versions this requirement will be deployed, the project management, we provide some navigations facility from the system design environment in Capella to the ALM. So the goal is not to reinvent the wheel. For the requirement engineering, we don't import all the system data inside the ALM, but we prefer to use a linked data approach. So it's a kind of proxy, again, to show inside the ALM all the information about the traceability to the fine-grained system data. And again, some capability to navigate to detail of these diagrams without breaking the experience of the web editing of the web browsing of the requirement user. For doing this, one standard way which is available is OSLC. It's a standard for interoperability across plenty of different tools to expose data, but without the need to import and export them between tools. So each data is managed by its own tool, but it is exposed in a linked data way, so with some ID. So you could imagine to have some traceability, some connection across all your tool or your repository of engineering data. One specific domain in OSLC is our OSLC architecture resource to expose such modeling. So that's the way we expose this, and that's the way it's enabled to have lots of different connectivity capability across plenty of different tools. Now let's come back on Arcadia and Capella. As you can see on the left side, you have the methodology of Arcadia, and you can see that requirement is a central piece of such methodology, and the requirement help to create the traceability across the different phases of your design. For doing this, the idea is to take all the data of your Capella models and to expose this to a high-speed server which will be responsible to expose all this data through OSLC interfaces. In terms of user experience, you have a system engineer which publish versions. The repository then is alive with these new versions. On the other side, the requirement engineers can create a new linked item under a requirement with an association role, depending on the kind of association role satisfied by, implemented by, refined by, I don't know. It can activate a new provider, and this provider can be populated by this server. So you can search Capella model directly inside your ALM user experience without breaking the flow. And then you can have several link items under your requirement, which are listed. And of course, you can share this with other people which are access to your ALM tools to review these associations and validate this without the need to have all the workbenches of the system engineers. Let's go on a video on this to see this in actions. So you are inside your workbench. You say that I want to publish my model to a server. I have still my credential, of course. I select the good models, and then it publishes on the fine-grained element, even the diagrams, and you can first verify on the web that your data has been published. Then, and of course, for the update, it's the same UX. And you can push your data. It will erase your data, but keep the traceability link you already perform and you already create. Then I declare in my ALM a new OSLC server, which is a server I just presented before. And I can go to a requirement. Here it is. In this example, I am inside Polarion. I open an item. And you can see that there is a linked work item. That's all the items which are populated by external data server. I select a relation roles. And this time I can say, okay, I want to search in an external repository an element to point to. So we are still in the same user experience and same web pages of your ALM, but this time we provide this UI. I can search, I find the trigger alarm, and now I have an association with a fine-grained trigger line. I can still click on it, and I can see the internal content directly from the web. So you can imagine to have lots of fine-grained linked item under your requirement in this way. Another important aspect is to provide guidelines both for system engineers and requirement engineers to be aligned on a common methodology. For this, a methodology has been built now for years and years, built initially by Thales. I think tomorrow they will have a talk from Jean-Luc Voirin, which is one of the authors of Arcadia. And this methodology helps to provide a guidance to know how you can capture some operational analysis, how the user has to interact together, then the systems, how the systems as a black box is defined, what are the interface with the other systems, then the system as a white box, then the allocation to physical architectures. And with this, it's helped to provide a kind of framework of decomposition, of split of concerns across your different engineering activities. And of course, your requirements in this way are better organized because you know at which level you are speaking about requirement. For example, here is an overview of the methodology Arcadia. And you can see that there is on one side the need, on the other side the solutions. So when you discuss about the requirement with your customer about his need, you have a full and very convenient split inside the system models that it is just on these two layers. The user don't have to care about how internally you will do your own choice. But you will, when you will do your own choice, you will design your solutions, you will do your breakdown of subcomponent, choice of hardware systems, you will have still a traceability from his need, from his requirement to the element you choose internally. So providing such guidance is really a game changer to deploy widely your methods and your MBSE approach. Another very important aspect is to use the right representation for the right job. Previously, some people say there are textual requirements and model design. There was a paper at INCOSE, I think it was last year, which won the award of best paper of INCOSE workshop. And it introduced the aspect of model requirement. When you do a system design with models, you are doing a kind of requirement, but it's not textual in English. It's just more structured thanks to models. But that's also some models. That's why also you are doing the both in the same way. So when do you need to use textual or to use requirement? Sometimes textual is more convenient for environmental considerations. For regulations, it's not really design block diagrams. It's clearly more convenient to do this with textual. If you want to just organize MS Word documentations, specifications in something more precise, also a requirement can be quite convenient in this way. Models are better when you need to describe behavior, like state machine, like functional flow. If also you want to coordinate verification and validations, you can use functional chains to organize this fluently. You can also better precise the performance constraints on one specific port, one specific flow, one specific function. For the architecture building, you can also design interface in a visual way. Data flow, it's clearly, even in the word flow, it's more convenient to have this as a graphical aspect to see what are the different branching of your flow. So here's a quote from Juan Navas at Capella Days, a great event which occurred several months ago. And he said that model plus textual requirements bring clarity and rigor to contract between engineering levels. So it's really help to define a precise contract when you go from one team to another one or from one company to another one to help you to be sure that everybody is aligned. You should also use the right tool for the right job. So, example, you are designing in your workbenches, then you want to create a new textual requirement. There is a magic key on your keyboard, the Windows key. With this, you can do, come on. You can use this to just split your screen. So you put on the right side your ALM, on the left side your workbench, and you will create your workbenches, your requirements, in your ALM. You will not use, you could not use your system engineering tools to create a requirement, but directly your ALM. So by doing this, you will enjoy a rich text editing capability, the possibility to attach a file, attach image, and so on, search, organization, plenty of stuff in the UX you already use. And by having the two, you just drag and drop as I already saw, and you have this kind of complementarity, which is quite easy. And in this way, you don't need to create your requirement in your system in workbenches and then to do the synchronizations, to organize lately where the requirement should be under which folder. And it could be a new way of managing easy to use workflow by having these two combinations. How many steps to read detail of a linked element to verify the traceability? Today, if you are an ALM user, you need to select the linked element in the ALM, then to open the workbenches, to check out the project, to find the element, to read its property, or you can just open a web page to just have the details of the property of the element. So in this way, we still publish new versions, and we expose this thanks to the servers. I didn't mention the name of the product I speak about from the beginning, which is called Publication for Capella, which is hosting all this experience. And you have directly in the web an easy access to the diagrams and data without any installations. So here is a little example of the experience. You can navigate across the different diagrams, even in the diagrams, without any installation again. You have the full content of your diagrams, so it's help to share the content of your system design to people outside of your teams without any barrier of installation checkout of the project. And even on the project, you can see in which ALM project this system project has some link with. Another aspect is, based on some use cases I saw, try to don't generate all the requirement for system modeling workbench without a strong need. It means that doing a design in a visual way with a model, then generate thousand and unit sentence from each port, each interface, each attribute, you take a risk of pollute your models with your requirement management with too many information. Sometimes you need to do this because you have a contract which forces you to have everything in a requirement, and it would be the contract. That's why I say that it could be a strong need. But if you can avoid, you can keep things simple, and just take this example. If just in a simple diagrams like this one, where you can easily see the mapping of function on logical component, then on physical hardware. If you want to translate this in unit textual requirement, it will be very hard to manage. How to use publication server to store version of your models. You will just not, because the goal of this is just to expose your system data through API. Again, use the right tool to the right place. Use SCM as usual to manage your versioning, the storage of your models. And the published version can represent the very last draft of your models, the last stable version or previous baseline. That's up to you. To conclude, I focus the mind the gap of ALM to MBSE on requirement, but an ALM is more than requirement. You can imagine also, depending of the OSLC capability of your ALM, to manage the project management with association of functional chain to Epic if you are in Agile mode, the release management to associate a published project with a release, test quality with associate functional chain to test case, issue management, planning, and so on. And in this way, you create a connected engineering, very cool to use. In terms of interoperability, the tool I present to you today, Publication for Capella, is already available with a qualified integration with Polarion. As you can see on the video, we are currently working, and it's still an ongoing work on compatibility with Doors and with Doors Next, thanks to Jazz backbone. And we are working also with we consider other integrations to be sure that you can expose your system data to several ALM tools. If you want more information, I advise you to watch this video from Stéphane Bonnet, which explain what he showed at INCOSY about the textual and the model requirement collaboration. So thank you. I hope you enjoy. I will have a look if there are still some questions about this talk. So, are we able to see a global coverage between requirements and models? See if element models are described by requirement and vice versa. So if you are inside your ALM, under your requirement, you can see all the linked elements which are associated to your requirement. So yes. In the other way, currently we have what we call the backlink, which means that any tools, the ALM and Publication for Capella, know that there is a reference on the other side. So currently we expose the backlink inside the web server from at the project level, but we have all the information to do this at a fine-grained level. How do you manage update that can be done both on requirement and system models? How do you manage consistency? So when you, for example, you drag and drop your element, you can then update your requirement definitions directly on all the projects. So all the requirement will be updated in one step, or requirement by requirement. When you publish your system data, you can choose to create a new baseline, a new project to expose because you consider that it's a new branch, it's a new way, or you can erase an existing project. In this way, the new version will be published and will be accessible to the ALM, but the traceability link will be conserved. After, does it trigger an event on the ALM side? That's up to your ALM and depend of the capability of your ALM. So I don't have any generic answer for this. Which ALM tool is compatible with the requirement drag and drop function in Capella? Today, only Polarion. For the other tools, that's something we consider today. It's something we propose as an open innovation. So it's services, professional services for doing the integration, just because it's really depend of the capability of the ALM to be able to detect the event of the drag from our side. So we usually with web-based ALM, we could be optimist to be able to have some information, but it's need to be studied ALM per ALM each time. How do you manage security issue for data? So in the v1.0 version of publication for Capella, all the users which have access to your server have access to all the data. So which means that you have to use the security to manage the security at the LDAP or Active Directory level. We plan to work on more fine-grained authorization rules to details read-write access for any kind of populations, depending of also your role on the LDAP or the role as a user. We also would like to create new collaboration with external partner from ALM provider, but also other engineering tool which want to leverage the Capella trend and use Capella data without reinvent the wheel. Just in terms of trend, today I think we just saw this this week. We reached 400 of organizations which say that adopt Capella internally. So, and if you look at the trend, it's going up very, very fast, and so the adoption of Capella is going very well, and it's worldwide and cross domain.